Hey there fans, welcome to another episode of Celerity Technology. Today I wanted to go through a little bit more of my RGB DAC. I know many of you have subscribed to my channel just for the purpose of getting to know more about this device that I've been working on. I am no way, shape, or form an electronic engineer, but this is more of a hobby that I've really developed in the 8 past months. So it's been quite a bit of a learning experience, and I wanted to kind of take you guys on the journey of how I wanted, or how I came into this hobby. So, as some of you have seen my RGB video with the thermal take fittings, I wanted a way of controlling each one, and well, nothing existed in the market. So I started working. This was my one of my first prototypes. It's partially disassembled, but this goes into show you like how I initially started. Granted, before this, I used what's called a breadboard to kind of prototype and see if it, or proof of concept to see if it would actually work, and it did. So I started designing a board like this. This one I ended up having to trash due to the fact that I put my MOSFETs the wrong way. As you can see, there's traces on the bottom which I had to hand solder, which was less than fun. I mean, this took more time than I like to admit, probably a couple hours just to do because of all the laborious hand soldering, and plus I was very new to it. So this is where it initially started, and I made 3 of these prototypes, and I don't have anything with me right now because I sent them off to some people I know to test and play with to give me feedback. So this is kind of where I started. After I got into that, I found out that there's this website called JLPCB, and there's many sites like it, and it's basically a small batch PCB fabrication company, and I thought their prices were really amazing. I mean, basically $2 for 10 boards, but if you wanted to get a stencil, that was like $8 extra. If you wanted to have it colored, it was like $9 for most of the colors, and black was like 18 bucks. And then shipping was like, from China, they were a bit expensive. I think it was like $20 or $30. So most of the cost was tied up in the shipping. So this was my first attempt at designing a PCB and from scratch. And as you can see, it has traces on the bottom. This is really my first learning experience, and it was, I actually had, unfortunately, I used some wrong pads for footprints for this, and it didn't fully work. So I basically scrapped this idea, and I moved on to my second one. So this time I decided to go with a blue to kind of try to vary each prototype. That way, if I had an issue, I could, that way I wouldn't get the boards mixed up, I guess. And also I wanted to see how they looked. So this is my second prototype. And as I'm new to the hobby, and I really don't, you have to gain experience somehow. So ordering boards and seeing how they work, and then trying some experimenting with them really kind of teaches you a bit. I mean, I found out due to some differences between some of the ICs I use, and also how some of the software controls the WS2812B LEDs, is that my red and green ended up being flipped on this board. So I actually had to double reverse it, so it would be the proper way. I wonder if that even is the correct term, double reverse. But anyway, I did it to the specs of the IC, but unfortunately I had to switch that because a lot of software uses flips the green and red. Some software lets you calibrate it, but not all. Like Corsair, because they intend you to use their items for their software, doesn't give you the option to calibrate. Like my Gigabyte motherboard, I was able to calibrate the board, and that worked fine. But I wanted to use Corsair IQ because it's a dramatically improved software compared to anything else out there. So a couple of the design flaws. One was the red and green. Also, I found out the hard way that these little strips that I made didn't fully, show you what people might use in the real world. And if you can see the difference between these two, one's much thicker than the other. Come on, autofocus, you can do it. So the problem is when I tried plugging in this bigger fat one, it would actually butt up against the next connector. So I had to spread out my headers. And another thing is I had an orphan trace, which means the trace that should have gone to the motherboard out did not. So then onto the actual, this is one of the boards that I've assembled fully, and as you can see, here's the headers. And if I plug this in here, I don't know if it's good view from that angle, but as you can see, plugging something next to it would be a little difficult. Okay, get one of these. So yeah, that's really tight, and if I had something similar to this, it definitely wouldn't work. But I'm actually using three of these boards with a different header, because Thermaltake uses the what are they? Like the fan header styles, and thicker pins, square pins. So I use those for the 3 RGB DACs in my PC. And what else? Oh yeah, also I switched. I do have some solder jumpers that allows me to switch the voltage to these headers from 12 to 5. It's not something that I intend users to do. That's why I want it to be soldered, so that way people don't fry something. Moving on to which will hopefully be the last prototype, is white. So I actually even included some pads and for some RGB LEDs, but I decided not to add any on because it's kind of annoying when you're working with double-sided PCB, because it's easy to do everything on one side, but when you do everything on the other side, it's less than fun, because you have everything on the other side, and this stencil doesn't work all that well when you have that. So anyway, I designed these, and I think I spent it's probably about 40 or 50 bucks for the runs on these, and I'm impressed. I think they look really professional. They came out very well, and the site again is called JLPCB, and there's other fabrication sites that are similar to it. I haven't compared those as far as price, but I really can't complain. I mean, they have an interface that's easy to use, and you upload it. And I designed all these boards in KiCad, which is an open source free tool. I can have some bugs every now and then, but I rather enjoyed it. So I try to put many hours of thought, and probably hundreds of hours of thought into these boards, because the idea is I want to kind of make this idiot proof, and that's not always possible, but that's sometimes why I don't just turn around and just build these things left and right, because I'm trying to kind of perfect on it. So I ended up from these boards I ended up making 2. So here's my 2 latest prototypes right here. Backside, the general design is the whole spacing and these standoffs are designed to be able to be mounted to a 2.5-inch hard drive caddy. I designed it to have you have 2 inputs. I'll start with this one. So you have 2 inputs. One's motherboard in, the other one is Corsair in. On the motherboard in, I actually have one of the pins blocked. I stuffed a pin that I broke off and shoved it in there. That way people can't reverse the polarity. For this male connector, I just clipped off one of the connectors so it matches up, so they can't reverse the polarity as well. You can only use one of these at a time. I didn't bother trying to see what would happen if you try to use both at the same time, but it probably wouldn't work all that well. So it has 2 outputs. You can output this to a lot of different devices that use the ASUS, MSI, ASRock, and now Gigabyte header. and also you can output this to another Corsair device. I can actually daisy chain these together, so it comes out here and goes into here, and now they're connected. So another thing I had to consider, these boards are actually slightly different, and they're headers for the analog. So if you can see here, these are male headers that are right here for the analog, and this is actually females with couplers. In the analog world, it seems like everything is female and you use these little male couplers, though that's not always the case when it comes to some of the computer devices. Like I see some fans and a few different devices have the male pins only, no female. So you know, I thought it'd be best to have just females and these males. That way, it could work. Also, I found out the problem with these is there's some different connectors. Like this has a little bit of a shroud in front of it that prevents you from plugging it all the way. So that was one problem. It just doesn't stay on. But if you plug it in here, it fits on much better. So what else? The other thing that really annoyed me was figuring out how should I supply power to this. And at first, as you can see in my older prototype, I had the cable soldered directly to the board. But the problem with this is movement of the cable creates strain on the wires, and when that happens, it weakens it, and eventually it could potentially break. I mean, if it's just sitting in your computer, you only saw it once, then you should be fine. But the issue is if you move it like too much, there's a potential that it could break, and then potentially could short something out, and I didn't want to have that happen. So I tried to figure out what the hell I should use for this type of connector, and I just came up with maybe I should just go with a male fan header. This way, people won't. If I had there's not really much you can do to screw this up. I mean, it's keyed right here. It's different than all the other connectors on this board. I mean, it does look like a fan header, and that's actually ground, 12 volt ground, and then 5 volts. So it's kind of weird how I did it, but it does work fairly well. So I ended up getting these little cables, making these little cables right here, and apparently that one. I guess I'm still working on my cable skills. Let me get this. First time I've actually terminated these, but let's see here. Yeah, so I think this cable might be actually slightly too thick for the connectors. So I'm going to have to source something else out. It's kind of just a hack together, but the idea is if you use, I need something small. I didn't want to use Molex. Trying to mount finding a SATA header, it was difficult as it is, and this is way too big. So this plugs in perfectly fine into that. And the other option is if somebody wants to, where is it? If somebody wants a longer cable, they could just grab a fan extender and just plug it into this. So that was kind of my thought. You need 4-pin fan, but you know, it works. And that was okay. Got all of these. And that was kind of the thought on that. You know, if I used a standard fan connector, then they could actually use a extender. That way I wouldn't have to make a really long cable, and these can be sourced for fairly cheap. So I wanted to also talk about how these things are assembled and built. So you have two different technologies that are used in this in a broad term. You have through hole and surface mounted. Any place you see you see these little, pokey things, little pins coming through the other side. This is through hole, so that means it goes through a hole and it's soldered from the other side. And this takes a bit of work, and this is actually more expensive to do it actually in the production world. Then you have surface mounted technology, and they call this also SMD, SMT, and every little device that you see mounted on the board uses surface mounted. And the cool thing about this PCB fabrication shop is you can buy what's, also forgot to mention that these can be stacked. That's why I wanted to use 90-degree headers. So I thought that would be kind of a cool thing. And one thing you can buy from them is is called a stencil. So let me see. I don't know if you guys can see it. It's like these little holes. I'm just reflecting the light back at you. So there's these holes right here, and it's exactly a stencil. So I use some cheap PCBs that I have, and how does this go? So I just set my board in here, and then lay the stencil down, and the stencil lines up with, did I have it right? And of course I did it dyslexically. Yes. Being dyslexic can cause some issues. It's a good way to damage some stuff when you're working on it, but I do test all my stuff. So basically the stencil, the holes in the stencil line up with all the different little pads that you see on this board. And what you do is you get this syringe filled with solder paste. It's basically these kind of microscopic balls of lead and tin suspended in this this flux, and you just distribute it onto this stencil, and you just brush it across. And what it does, it layers in an equal amount of solder paste across all the little surface mounted pads. And once you lift it up, you just take it off, and then comes the fun part. What you do is you get all the different little resistors, transistors, integrated circuits, and you start with the smallest ones, and you just pick and you place manually everything. And this is a very time consuming. It's not that much fun to do. So this is why I'm not, this is why most of these boards haven't been built out, because I work full time. I have a second job as a dad, which is, God, that's a job and a half in itself. Being a parent is difficult. So yeah, it's pretty much nights and nap times when I get to work on stuff like this, and sometimes I don't always have the energy to do it. But anyway, yeah, so you basically pick and place this, then I get a really a temperature controlled hot air reflow gun, and I basically go over each individual component, and what happens is the solder paste melts reflows, and basically pulls the little surface mounted device centered. So I mean, and you also have to, before you do that, you have to look and make sure that your polarity is proper, everything's lined up, and you have things facing the right way. Or you could damage, like I've damaged ICs because I put it down and I didn't really look close enough, or I reversed. It's amazing how much you can damage stuff when you're not paying attention. So I always try to check, double check, triple check to make sure everything's fine. So after that, you end up with a board full of SMDs, and I come back and I basically put all these different headers in, and then solder them on. The thing is, you don't want to surface mount these, because the way this works mechanically, being held in place like this, is actually a lot better than surface mounted, because the surface mounted could just break off. It won't take the stress. And if I don't know if you caught it, like my where's one of my cables? Like there's the first cable made like this, and I thought I had it on enough, and it came off. So I think these cables are a bit too thick for this, but I wanted to throw something together quick for a example. I wanted to do something off the cuff, and I will do a demonstration, a couple-minute demonstration on a video probably tomorrow or in a few days. If you have any questions, feel free to post it. This is something I'd I would like to produce, and I do have a couple minor tweaks, but I'm looking into getting this mass produced. Can be a relative term, maybe 50 to 100 or whatnot, depends on how much interest there is, and basically hire out a factory in China that can pump these out, pick and place, use a pick and place machine, which uses a little pneumatic, computerized machine that literally takes these SMDs, which are located on little trays or reels, and just sucks them up and just places them. It's a real fascinating process. You just check it out on YouTube. I mean, EEV blog has one, and I think Strange Parts. I think he did a tour of JLPCB, and that's really cool. It's like amazing how much what they do to get these boards. It's just brilliant. But so I'm going to try to look for a shop that can supply the components, that can make the boards and assemble them all together, and then just ship them to me, and maybe I can sell a few to recoup some of the costs that I put into this hobby. You just want to want to control something in a certain way, and then you end up spending like $1,000+ on a hobby. But I mean, I've enjoyed it. So hopefully I can make some boards for some people. I might even sell a few of these white DACs. Granted, I have to improve my crimping skills. But if you have any questions, feel free to post them in the comments. Thank you very much for tuning in, and feel free to subscribe if you haven't. Have a wonderful day.